contractors and separators with PyIbex. So PyIbex is a Python library which uses ibex, which is devoted to contractor programming. This exercise illustrates how to use PyIbex on simple examples. So I will consider the same example first as exercise 6 about the forward-backward contractor. So I have a set S0 which is a subset of R2 and it corresponds to the set of X and Y such that there exists CXCY inside these intervals such that this constraint is satisfied. Of course, I will have to draw the paving associated to S0, so an inner and an outer subpaving, and for this I will use vibes. I have already done this exercise without PyIbex, and I will show how elementary operations can be performed with PyIbex. And later I will use, of course, some more powerful tools of ibex, such as this forward-backward contractor. Okay, so I will start with my program I have done for exercise 6, and it was my ring. So now I will call it file save as, and instead of calling my ring, I will call it, let's say, my will be replaced by PyIbex ring. Record. I will start running first to recall what it is doing. So I execute it, and we can see here the contractor, so it is a set, the solution set here, and I have only an outer approximation because I only use a contractor and not a separator yet. Okay. So now to use ibex, I will show. I will first from import everything in PyIbex, so like this, import everything. Of course, it's better to import only what I need, but here for simplicity, I will import everything. Import PyIbex, so that I will be able to use this as a namespace, and I will not use anymore my all interval libraries such as my box, my contractor. Everything is in ibex. Okay, so to define a contractor, I should first define a class with I will call it my contractor, my CTC. So CTC is for contractor, and it derivates from contractor CTC. Okay. So this contractor, I will define the initialization, the constructor, underscore init with self. Okay, the self, I will call it, for instance, C. C like contractor. So CTC dot. So I will call the constructor associated with the class CTC with C and 2, so it corresponds to the dimension of the box I want to contract. Definition, contract. contract. So C, and here the box X. So it's a box X and Y. So I will first rename X and Y. For simplicity, it corresponds to X of 0 for X. So the first component has to be number 0, and the second one should be number 1. So X and Y are two intervals now. I will now initialize as given in the exercise. I know that Cx, Cy, and R. I will initialize them. They will correspond to interval. So for Cx it will be 1 and 3. For Cy it will be 2 and 4. And for R it should be 4 and 5. So why? Because it is written here 1 3 2 4, and R correspond to it is not written, but in the previous exercise it was 4 and 5. Okay. So now I will, as defined here, it was my old contractor defined here, so I will take some sentences here. So copy paste. I will put them here. So here I will write, let's say A and B. A and B. So A and B corresponds to X minus X, and this one also. So here I change nothing. Okay, so I will continue. I will write that A2. So I will initialize A2, B2, R2, and they will be equal, B2, R2, and they will be equal to square of A. So this one is the square of Ibex, square of B, square of R. So I have initialized these intervals. I have the constraint A equal to X minus Cx. Of course, I also have other constraints such that B equal to Y minus Cy, and so on, but I will only consider the first one. I represent like this. Here I have minus, here I have A, here I have X, and here I have Cx. So if I have some intervals like this, so this is an interval, Cx belongs to this interval, and A belongs to this interval. So for the forward propagation, I should have the interval A is equal to X minus Cx. Now, for the backward propagation, I should do, as explained in the previous in the lesson, X equal to A plus Cx intersected with X, and also I should have the same with Cx. So equal to X minus A intersected with Cx. This corresponds to this one to the forward propagation, and this one corresponds to the backward. For this, I have a specific. This one has already been implemented using the intervals in my program, but now to implement these two lines, it suffices in PyIbex to write backward subtraction, because sub, and I will write A x and Cx. So recall the order here is the same as here. A x and Cx, here A x and Cx. Okay. Now let me come back to my program, to my Python program. I will have to write somewhere backward sub A x and Cx. So it corresponds to the two interval instruction written before. About the second one, I will also write backward B, Y, and Cy. So these two lines correspond to the backward propagation associated with these two forward propagation. Okay, now I also have a computation of three variables with respect to A, B, and R, and I should also perform a backward propagation. So I will write here backward underscore SQR of A2 A, the same for B, and for R, I know also that R2 equal to A2 plus B2, so I will write backward backward add, because it is a sum of R2 A2 B2. Okay, so this corresponds to, so this line backward addition corresponds to this, except that here I was also contracting R2, but here I don't need to contract R2, so it is not needed, only a backward propagation is needed. These two lines correspond to this one, and these two last lines, this one, these two lines corresponds to these two lines. Okay, so I can remove this, I don't need it. And as we can see here, x is a reference. So when I modify x and y, which correspond to this one, it will also modify x0 and x1. Okay, so now let me come back. Civia is not needed because it exists. It is a paver that already exists in PyIbex. Okay. So I remove this. I don't need it. Now I have my program if main. Probably here I don't need it. So I remove this. Begin drawing, new figure, so one ring with PyIbex. Okay. Set figure properties, probably I should put it more in the center. And here if the width could be okay. X could be an interval, so with PyIbex it should be interval vector and not box. So few things change. Here it's a vector of dimension 2. And I will put here with this syntax a list. Now once I have defined the initial box minus 10 10 times minus 10 10, I should declare an instance of my contractor, CTR for instance, my contractor. Then I will call the CVIA of PyIbex, so Py CVIA. I have to put x0. The contractor I have just declared, and the accuracy 0.5. I don't need the last sentence because it will close it automatically. Of course, here it is x0, CTC. It should not be exactly at the same level because it is a main program, so I will have to dedent. And probably I have, yes, here, as usual, this. Okay, I run it. Invalid syntax. Here also. Okay. And I have drawn here with vibes the ring. Second question, I have to do the previous question, but using some statements such as the contract forward backward of PyIbex. So of course it will be much more easy to program. So in fact I will not need to implement this class, to implement my own contractor. I comment this because probably I will need it. I don't need this. Okay, so I start from nothing. I will okay, this vector, so minus 10 10, but also I could have written this. It's the same, but if I want to write this, I have to put brackets here and also here. It is the syntax of Ibex. Now I will have to build my interval for R equal interval 4 5, and what will be efficient here is to declare a function. So f is a function. So this is in the Ibex library. To define this function, I should put first the input, so it will be x1 and x2. and here I will write my function. So my function will be x1 minus an interval, so the interval will be noted like this, 1 and 3 square for the then I will also have this one plus, so it will be x2 minus 2 and 4 power 2. I have defined my function. And my contractor will now be defined as CTC forward backward, so it recognizes it, of f and square of r. Okay. So in fact, what is very nice with ibex is that I can define this function even with intervals inside, and I have plenty of methods, very efficient method, such that this one is one among many of them. I have many methods to build contractors and to combine them. I will then call my Civia on this contractor. And at the end, vibes, I will, to avoid to have homogeneous axes, I will use axis equal. Okay. So I don't need this anymore. As we can see here, the program is very simple. I run it and I obtain the same result as before. If I want a separator now, I just have to declare here the separator, write here separator, sep, and here sep. With a 0.1 for instance, or whatever. If I run it, as we will see here, well, of course it takes time, but nothing had changed because it was not able to find an inner and an outer approximation. So to have this, of course, is due to the fact that here the accuracy is the inaccuracy is large. So these parameters for C1 and C2 are large, so it is impossible to find an inner approximation. But if it is small, for instance, let's say 1.3 here, and here 2.3, so it is now quite reasonable. I will obtain here an inner and outer approximation, but we can see that the frontier, the yellow frontier, is quite large. So it takes a lot of time to compute inside, but I have an inner and an outer approximation, even with uncertainties on C1 and C2. And if this uncertainty disappears, of course, the yellow part will converge to a very thin frontier, as illustrated here. Okay. Okay. So now about the other question. I have the two rings, also have been considered in a previous exercise, and here I will have to compute a separator for S1, a separator for S2, and to perform here the union and here the intersection. So here I will define my two functions. F1, it will be the function of So I will use a vector notation of 2. So with 2 components, I will remove this one. Here I will have 0. So of course I could have kept the scalar notation, but here I use a vector notation, x1, which takes place of x2, the previous x2. Here the center will correspond to 1, and this one will correspond to 2. So why this? Because it was written here 1, 2, and here I will have 4, 5. Okay, so about my separator, it will be, so for 5, I will keep it for later. My second function, f2, corresponds to the same, but here I will change the radius, no, the center, and 5, as given in the exercise. And then I will build a separator here, which corresponds to separator forward-backward f1, and here I will have the square of the interval, this one, and this one will correspond to the separator number 1. For the second one, separator number 2, I will have separator forward backward, I will have the function number 2, and the interval will be 5 and 6. Then for PCVA, I will call it sep, which corresponds to sep equal sep1 intersected with separator 2. Okay. I run it. Invalid syntax. Yes, I have to remove this. And I obtain with vibes this intersection between the two rings. If I know now I want to get to have the union, I will have to write here the union, and I obtain now the union of the two rings. So one of the main advantages of PyIbex is to be able to build contractor and separators very easily thanks to the contractor algebra